Hello everyone, my name is Vinayak Kohli and today I am here with my teammates Nishant Toma and Nishasvi. Today we are presenting a project on a hybrid movie recommendation system. Let me start with the problem we are trying to solve. Given a user history of movie interaction, the goal is to predict and accurately rank the movie that the user is most likely to watch next. This sounds straightforward at first, but in reality, it's one of the most hardest problems in applied mathematics, applied machine learning. And here's why. The MovieLens-1M dataset that is shown here has around 1 million ratings from 6,040 users and across 3,900 movies. But on average, a single user has interacted with fewer than 0.05% of all the available movies. That means the data is extremely sparse, and the most user movie combinations have never been observed. So any model we build must generalize well for very few data points. And here's the models. And the second challenge is that no single model dominates across all user types. Popularity-based models work well for cold start users who have very few ratings. Graph-based models capture structural relationship patterns. Sequential models focus on recency. Deep learning model captures on non-linear feature interactions. If we pick just one, we lose the benefits of all the others. And finally, this is the ranking problem. Different models produce different scores on completely different scales. You cannot just add one score and another score together and expect a meaningful result. So to address all these challenges simultaneously, we designed a multi-stage pipeline that progressively defines recommendations. We start with the raw data, that is movie 1 million and Kaggle 45 for enriched metadata. In our multi-stage pipeline, we convert it into the right format, generate candidate using different models, enrich those candidates with single small language model, that is Gemma. Uh, we train that model to a learn to rank model on top, evaluate rigorously, and present the result in an interactive UI. That is this. And our results speak for themselves. We achieve a hit rate of, that is shown here, hit rate of at k is equal to 10, 0.797 and NDCG of k is equal to 10 of 0.636, meaning we place the correct movies on top of the top 10 for nearly 80% of the users, and beyond accuracy, we achieve 78% catalog coverage. I will now hand over to my teammate who will walk us through the data process and generalized candidates.
So hello everyone, my name is Yashasvi. Now I'll walk through exactly how data flows through the first half of the pipeline. The first is the data loading and bannerization. We load ratings, movie, and users from data. Each rating record has a user ID, movie ID, which is basically scaled from 1 to 5 star rating and a timestamp. Since we are treating this as an implicit feedback, we apply bannerization. So in this bannerization, we are basically rating 4 or above, basically 1, and rest we dropped entirely. No imputation, no mean feeling. After this, the rating value is never used again. The threshold and the minimum interaction count of 3 are both configurable in YML file. So after filtering, we are left with the 6,035 users and 3,807 items. Now the next step comes train validation test split. We split using leave one out, in which for each user interactions are sorted by timestamps. The last interaction goes to test, second to last to validation, everything before to training. This mimics predicting what a user watches next based on their past. Now the next step comes the negative sampling. Since we only have a positive evaluation, we need negative. For each user, we take their one true held out movie and sample 99 random items they never seen. These 99 negatives are frozen and one stored in the negative.py. Uh, so every experiment evaluates on the exact same pool of 100 items per user, making results fully reproducible. Now next step is the candidate generation, in which now we generate recommendation score using 7 models, all 7 models, Each model independently scores every user item pair and writes to the packet file to data processed file. So first comes a popularity model, in which it basically ranks item by global interaction count, simple but strong for cold users. Can you show the pop file pop.py popularity? Thanks. Now, now the second model is item canon, which basically score item based on the cosine similarity to what the user already watched. Now, then the next model comes is basically learn a closed form item to item weight matrix, linear but consistently competitive. The next comes the PPR model, which basically learn user item embedding via pairwise ranking, positive item ranked above sampled negatives. Next comes the LightGCN, which propagates embedding through a user item bipartite graph across multiple layers, capturing higher order collaborative signals. Next comes the DCN, which basically is a explicitly model bounded degree feature interaction via a cross network alongside deep layers. Now, second last is the NeuMF, which combines the matrix factorization and an MLP branch capturing both linear and non-linear patterns. Now, last but not least, the last model comes the SASRec, which basically applies self-attention over the user's interaction sequence with a casual mask capturing recency and temporal patterns. At the end, this stage, we have 8 package files, one per model, each containing user item scores. These feed into the next stage. So I'll hand over for the LLM and final rating stage. Thanks.
Thank you, Yashasvi. Myself, Nishan. Now let me cover how we enrich and combine these scores into a final proper rankings. All 7 CF models only see interaction patterns, not what a movie is about. To add a semantic signal, we fine-tune Gemma using LoRA, low rank adaptation, which updates only small row rank weight matrix instead of full model, making fine-tuning feasible. Building the training data. We build our training data using build LoRA. Vinayak, can you show that? This transcript, whose output is then stored into a JSON file. For each user with sufficient history, we sample positive and negative movies, construct a natural language prompt containing the user's watch history and the candidate movie's metadata, and label it yes or no. Then we are doing training, which is in script LoRa train.py. We are training our data and then saving it to a checkpoint. The LoRa adapter is fine-tuned on these prompt responsive pairs. Then we are doing inference. For each user candidate pair, we pass the prompt through the adapted Gemma model and extract logits of yes and no tokens. Apply softmax and store these probability into LLM yes probability, which is between 0 to 1 semantic compatibility score. Then we are doing a feature engineering where we are assembling one feature vector per user candidate pair. Vinayak, can you go to train final model? Here we are showing here we are assembling these. The 8 CF scores are on completely different scales, so we apply rank normalization for each model, and each user items are ranked by score and converted to 0 1 percentile. This ensures every model contributes equally. We add 2 user features and 2 item features. For user features, we have interaction count and average popularity of items they have watched, and for item, we have interaction count and popularity rank, all derived from data process training file which we previously previously stored. We append LLM yes probability from LLM features file, and this gives us 13 dimensional feature vector, 8 normalized CF scores plus 2 user features and 2 item features plus 1 LLM score. Then the meta learner takes this 13 dim vector and learns to produce the optimal final ranking, which we are doing in tune meta learner.py, and also side by side train final model py. We combining these two files, we use LightGBM LambdaRank, which directly optimizes NDCG via pseudo gradients, unlike classification or regression models that optimize proxy losses. Samples are grouped by user so ranking is optimized within each user's list independently. We run Optuna HPO to search over learning rate, tree depth, number of leaves, and regularization. The study is saved to checkpoints again and can be reused. Best parameters go to results best parameters.json. The final model is saved as meta in some checkpoint file. All the matrices are computed in scripts run pipeline.py on the frozen 100 item pool per and saved to results hybrid pipeline.json. Here we get a hit rate of 0.797 and NDCG at 10 which come out to be 0.636 approximately. Back to person 1 which will show us how the UI of our project.
Thank you, Nishan. Here I will explain our UI. So this is our UI of our project. In the left, we have a user ID. All the users are in the drop-down menu here. And this is the user history of every user. And this is the top 20 movies that we recommend for every user. And this is we can choose different movies from here, and we can get if we recommend these movies or not. It's an unlikely match, and we rank this movie out 62 out of all the movies. And this is the relevance score, this is the ground rank, and we negative sample, so we don't recommend this movie. Let's take an example of user ID 1. The most common in the watch history, the most common genre is animation, comedy, children's comedy, musical. So we are in top 20 recommendations. The most movies of genres are children, comedy, musical, as you can see here. But to add diversity, we also added movies of genre like drama, romance, war, crime, thriller, adventure. These are all for diversity purposes, but we also added for likely if the user will like it or not. This is the top 200, and right, we can choose different movies like this. We also see different score for different user. Let's choose a different user like 34, 36. We can see the user history of user 36 and top 200, top 20 movies recommended, and if we recommend string movie to him or not. As you can see, string movie is highly recommended, and we can see all the string movie here. And genre diversity, we also see genre diversity and average novelty of every user. And when we go to the bottom of the UI, we can see the average matrices of the whole project. We can see diversity, average diversity across all the users, that is in the top 20. Average novelty across all users, average coverage, and personalization across all users. And we can see the graph of hit rate and NDCG that we can see for k is equal to 1, k is equal to 5, 10, and 20. As you can see, as the k increases, our hit rate and NDCG are increasing. And so this is the whole UI. Yes. And this is our whole project of hybrid movie recommendation made by Vinayak Kohli, Yashasvi, and Nishant Toma.
Thank you.